Back in ancient Greece, there was this mathematician called Pythagoras, and he discovered this relationship about right triangles where if you take the length of the sides and you square them, you'll get the square of this side called the hypotenuse. And it was a really powerful relationship that he found because, back then they didn't have Xbox or television, so they really spent a lot of time discovering these math formulas. In a right triangle, the sides that form the right angle are called the legs, and those were the two things that Pythagoras was squaring. The side opposite the right angle, which is always the longest side, is called the hypotenuse. Please spell it correctly. And so that was the relationship that he figured out. Now here's what he said in words. For any right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Now, you know that as a squared plus b squared equals c squared, where c is always the hypotenuse. So let's use Pythagoras' formula and find the length of the longest side of these triangles, which is the hypotenuse. So first thing, anytime you have a formula question, is you always write down the formula. So I'll write down a squared plus b squared equals c squared. And now you plug in what you know. Now these are representing the legs because they're touching the right angle. You see the right angle right here? So those go in for A and B. It doesn't matter which one goes in for which, but what matters is that the hypotenuse goes in for C. So you show your work, you do your math. 5 squared is 25, 12 squared is 144, and then you bring down the C squared. Underneath is where you write down 169 equals c squared, not over here. You don't write 169 over here, you write it here. C squared maintains the right-hand side. Now, in an earlier lesson, we learned that the opposite of squaring is square rooting. So just like I would show division or I would show addition to remove the symbol, I'm going to show square rooting, and that cancels out the square. And then I have C equals 13. And let's put 13 meters. A big mistake that people make is that they get down to where it says C squared equals 169, and they think that the variable is by itself. The only time the variable is by itself is when it is literally by itself. There's no exponents, there's no other symbols involved. Maybe you have a 1 here, but that's okay. If you'd like to try letter B on your own, feel free. If not, follow along. First thing I'm going to do is write down my formula. A squared plus b squared equals c squared. And again, these two sides are the sides that are touching the right angle. So I'm going to plug them in for A and B. So 8 squared plus 15 squared equals c squared. 64. That's 225 equals c squared. You don't write it here. You write 289 here. Don't put 289 on the right. You put it underneath. So 289 equals c squared. In order to remove the square, I show its inverse, which is square root. And then these cancel each other out. And you have c equals 17 feet. In this section, we're going to be using our same formula, the Pythagorean Theorem, but we're going to plug things in a little differently because we're going to be given different values. So the first thing you always start with is you write your formula, a squared plus b squared equals c squared, and this works for any question where you have a formula involved. It is always helpful to write your formula first. And then you plug in your values. Well, you see a is here, so a squared stays a. And then a lot of students will look and they'll think that this 2.9 is b. Now, there are two reasons why 2.9 isn't b. First is that the hypotenuse, which we know is the c value, has to be the longest side. So if you look at the two that are left, there's no way that this could be the hypotenuse if it's shorter than this value. And the final reason, or the second reason why you know that that's not b, is because it's across from the 90-degree angle. It's the side that doesn't touch the 90 degrees. And so that's how you know that it's the c value. So that means that when we plug in, we're going to plug in 2.1 into the formula. And 2.9 goes in for c. So now you grab your calculator and you write down what you have. So now you have a squared plus, that's 4.41 equals 8.41. And then you look and you go, what am I supposed to do? So if you forgot, hopefully this triggers your memory. This is all the way back from chapter 1. You need to get everything away from this a. So we have to do some inverses. So the first inverse I'll do is minus 4.41. And I get a squared equals 4. And then the final step is to square root to get the exponent away. So you just get a equals 2. So that means the answer is 2 centimeters. And I know that this kind of makes sense because it has to be less than 2.9, which was the hypotenuse. If you want to try letter B on your own, go for it. If not, write down your formula, a squared plus b squared equals c squared. Then you have to figure out what the missing values are. So here's a, and b is either 10.4 or 9.6. So think about what we talked about in this previous triangle. Which one is the b value? It's going to be the 9.6 because here's the 90 and 10.4 is number 1, longer, and number 2, across from the 90. It's the one that doesn't touch it. So this has to be the c value, which means this has to be b. So let's do 9.6 squared equals 10.4 squared. Grab your calculator, and we have to do 9.6 squared, 92.16, and 10.4 squared is 108.16. You have to get the a by itself, so let's drop a line. Minus 92.16. And we've got a squared equals 16. And I have to get rid of the exponent now. So I have a equals 4. So that gives me 4 meters as my answer. And I know that kind of makes sense because it has to be less than 10.4. If you have any questions, write them down and ask me when you come to class.